Okay, hello everyone again. So it is 3 p.m. Moscow time and we're ready to continue. So now we'll have a session on case studies. We'll have a number of papers and after it we'll have a number of keynote talks and a panel session at the end. So stay with us, and now I am glad to welcome our session chair, Alexander Naumchev, and co-chair, Mansour Haziev. So, Alexander, hello. Wait, we can't hear you now. Let's check it now.
Can you hear me now?
Yes, now it's perfect.
Okay, thank you. So our first speaker is going to be Apostolos Kritikas, and he will tell us about an empirical investigation of sentiment analysis of the bug tracking process in LibreOffice open source software. Please, Apostolos, you're welcome to start.
Hello, everyone. First of all, can you hear me?
Yes. Very well.
First of all, I'd like to thank you for having me in the Open Source Systems 2020 conference. Thank you for an extraordinary effort to make this happen remotely, and congratulations for the organization. It's been great so far. I'm very happy to be part of it, and congratulations to everyone volunteered and worked for this. Should I share my screen now? Is it okay?
Yes.
Okay. So our work has a title, an empirical investigation of sentiment analysis of the bug tracking process in LibreOffice open source system. And at this point, I'd like to take the chance and thank the two co-authors of the scientific work, which is Theodoros Venetis and Professor Stanelos, also my supervisor for my PhD work in the university. I will try and be brief, although we have lots of things to in this work, but due to brevity of time, I'd try and be brief. So a couple of things about the work. We tried to investigate sentiment analysis of the backtracking process of open source software, and why do this in the open source software realm? Because of course there are lots of data, and its main strength is that it continuously evolves, and it's maintained by the community. So we have a hugely dynamic system with continuously new information going in the maintenance field through the backtracking efforts of the community and the people that are working the software itself. Why LibreOffice open source software? It has a very rich code base. I'll give some numbers in a while. And it's a software that has a tremendous evolution through its history. I mean, it started as OpenOffice, and then there was a fork and a huge change in its community. It took many forms, and now it's still alive. It's still a very vibrant project, and we think that there's a lot of information there to study and do scientific work with that. Why sentiment analysis? Because we believe that there is a huge information in the community of an open source project that we have the possibility to investigate, and valuable emotional information may come from investigating the data coming from the bug reporting of the end users and the contributors of the projects. Our case study plan, as I said, LibreOffice has a rich code base. To the time of writing, we had 86,472 commits, nearly 2,000 contributors, more than 9.5 million lines of code, and a very active community, as I believe most of the audience already knows if they're using the LibreOffice project as I do. We studied 16 major releases, and I'm giving them in the parentheses. And from them, we gathered 740 bugs with 6,960 comments. In those, we have bug-related data, comment-related data, and we're also tracking the order of the comments, which is important for us in order to be able to know how the discussion went, who is answering to who in the thread that started from a bug reported. Let me here clarify that when we say bugs to our scientific works, we refer to threaded conversations that started from the initial bug reported. Due to brevity of time, I will not discuss one by one the parts of our data set, but I encourage the audience in the end to do questions on that part if they feel that they need clarifications. So moving on to our statistical analysis, we first needed to see the distribution of comments to have an idea on how the comments are spread in the different versions that we tried to study, and you can see this in the figure figure 1. We then moved on by producing some box plots to see if we have outliers and if we need to perform a data reduction to our data set. But in the end, we avoided doing so because the variations of the volume of the comments in most of the cases has been explained. For example, if you see some variations in the number of comments between the version 4 and 3, this happened because that's the point where LibreOffice was born from OpenOffice, and there was huge refactoring of the code, therefore huge activity from the community in reporting bugs in the changes of the code. So we didn't do a dataset reduction, and we moved on in producing the descriptive statistics of our variables, which is the ones that are depicting in table 1. And then, because as we see, there is a skewness near to 1 in some of the variables, we needed to perform a normality test, and we chose Shapiro-Wilks test in order to be able to see which of them are following the normal distribution and which not, because we were expecting that some wouldn't. Finally, as we see in table 4, we tried to find the correlation between the positive, neutral, and negative comments of the two sentiment analyzers that I will say a couple of things now. If the data between them are strongly correlated, in order to be able to know that our data have a significant to be collectively studied. Now, a question that we had, a comment that we had from the reviewers was why we choose to work with two different sentiment analyzers, and I'd like to take a minute and discuss that. The answer is because we needed some different types of data that the two tools were giving us. And as you can see in this slide, the Vader analyzer, apart from the basic sentiment score of a text, also gives us some variables that we want to discuss in this work, like the irony in a comment, or objectivity and subjectivity in the comments and the bugs reported. I will get to this in the discussion part. First of all, our initial goal for this project is to try and investigate whether it is useful and meaningful to discuss sentiment analysis on bug reports. And this question comes from from an intuitively observation that the backtracking process in an open source software mainly has technical text in the comments. So one might argue that why one wants to investigate sentiment in these kinds of text. So what we came across to our work is that, first of all, as you can see in table 2, in all of the versions that we studied, there is a mean significance, a mean confidence in the sentiment analysis more than 90%, which is over 90%, which shows us, which indicates that the tool is confident that it observed rightly the sentiment of its comment that we studied. Also in table 4, as we can see, although we used two different sentiment analyzers, as I said, there is a strong correlation in our analysis. So between the two tools, therefore, we have a clue here that the two different kinds of analyses are sort of finding the same results in the analyzed dataset. Our investigation continued with investigating other things that we can find in comments regarding the sentiment, like the irony aspect and the objectivity subjectivity I said. And here there were some good observations that were done from our results. First of all, we found little comments and bug reports that were tagged as ironic. And this is something we intuitively expected because, as I said, we mostly expect to find technical information in the backtracks, and mainly comments of people that are trying to report something that doesn't work. And usually they're not ironic doing that. However, there were some cases that were flagged as ironic tags in the discussion that followed a bug reporting. However, even in those cases, some of them were false positives, as the one I'm showing in this slide, where you can see in the parentheses where it was flagged as ironic only because there was a part of it in capital letters, which the analyzer thought it's someone that is frustrated and tries to express this frustration via text, which is something very common, for example, in social media, but not in the backtracking system. This in this case, the person doing the comment was trying to stress that this is a comment that is persisting, and nobody has done something for that in a long time. And I'm just stressing that it needs to be taken care of. As far as the objectivity is concerned, we don't have a strong finding on whether it's low on high or high in open source software, or in this specific open source software LibreOffice that we were investigating. But we also found that there are several cases that are misunderstood by the tools, like the one I am stressing here, for example, which, although it's not a subjective, it's not a subjective comment, it is mistaken as such because at some point the author are saying we are changing, which the tool implies that it is their own decision out of an opinion they have, and not because they know what they want to do. So as far as the threats to validity are concerned, we have mainly the problem that we have technical text and there is jargon related to that, specific terms. And we're also having personal comments by users that are using the software and they want to express their feeling and their experience. So sometimes there are personal phrasing and style of wording that are confusing the analyzers and are making the analysis a bit difficult. Moreover, there are cases of subjectivity from specific groups of users that are trying to make a personal opinion pass during a specific matter in a widely used software, or as is the LibreOffice open source software. And finally, I think what we intend to make use of in our future research, due to space limitation to the conference publication, we decided to group our research in the specific versions we studied, but the truth is that the data we have collected are more vast and can and so this investigation can be extended and looked more thoroughly in some aspects of the ones that we're investigating. So to conclude, as future work, we plan to repeat our experiment in other programming languages and styles of coding, like Java, PHP, so forth. And we intend to also include metrics and study it in parallel with the sentiment analysis. For example, in order to be able to draw some conclusions for the structural properties of the source code. Also, we had some proposals from the reviewers to also try and investigate other sentiment analyzers and see how the data are appearing in their analysis. And this is also something that we are thinking we're going to try in our future work. At this point, I'd like to thank you very much for hearing me. And of course, whatever questions you have, I'll be very glad to hear and reply. Thank you very much.
Thank you so much, Apostolos. I think we're unfortunately out of time for questions, but because we're in Zoom, we can continue the question and answer session in the chat. So I'm going to ask a question from my side shortly. So thank you so much, Apostolos. And I'm now passing the turn to Nikolai Rutyunyan with his talk called Challenges of Tracking and Documenting Open Source Dependencies in Products, a Case Study. Please.
Hello. My name is Andreas Bauer, and I'm here the main author of the paper, and I will present.
Okay. Sorry, because I thought.
Yeah, no problem.
Andreas Bauer, please.
As I said, my name is Andreas Bauer, and I'm the main author of this paper. And today, I'm a PhD student at the University of Erlangen-Nuremberg, and today I would like to present you this paper about the challenges of tracking and documenting open source dependencies in products. So from the motivation side, more companies using now FLOSS dependencies in their products. They see all the benefits that open source software brings to their products, but it's not really free for the companies. They still need to govern their use of open source software. Oh, now you can see my camera. So in order to govern the use of their FLOSS dependencies, they need to document it Otherwise, a task like license compliance would be impossible. And if they have ungoverned, if they do not govern their dependencies, they will have legal risk or financial risks. But the management of these dependencies has grown more in an ad hoc fashion. Most companies started without open source use in their products, so it was not really a main concern for them. And then later on, they added it on their models and on their kind of presentation. And another problem is also it's hard for vendors to learn from each other to improve these practices, especially if they're if they are competitors. So if you maybe know like the SPDX standard who allows or simplifies the exchange between license information between different companies, it helps a lot. But however, such standards or guidelines doesn't exist really to represent a product's architecture together with open source compliant relevant information. Okay. So before I talked about the current research, I want to emphasize previous work so that you understand why we are investing the time to research it. So in a previous paper about here industry requirements on FLOSS governance tooling, here we presented a hierarchical list of requirements that the industry has to governance tools. They're listed in different categories, and in one of the categories is tracking and reuse. There was one thing here, point 1.2, report the use of FLOSS components in their product architecture model. So among other requirements, it showed that companies develop their own tooling to incorporate all this FLOSS governance relevant information within their architectural information to manage their whole use of FLOSS dependencies. Yeah, and this emerging topic motivated us to look deeper into it, and it resulted in the current work I'm presenting you now. So let's talk about the research method. We conducted a single case study informed by Yin. For that, we chose a large multinational enterprise software company with mature FLOSS awareness and use. It was important for us to have a company who had really mature processes and tooling in place, so that we don't talk about like basic challenges like how to license scan some components, and to talk more about advanced challenges that the companies have. For that, we did several interviews. You can see there are different interviews partner that show insights from different perspectives. And we used to collect all the information, then used qualitative data analysis to have the traceability between the theory and the data it's built on. Okay, and then let's talk a little bit about the results. I will just talk briefly about here the results and go not too much into detail because of the time constraints. There are mainly 5 main categories. Like the first one is the data gathering process. If a developer wants to introduce a new open source dependency in a product, there is an approval process where you have to put in several information to get an approval for a component. This process is to provide all the information. It's a highly manual process. So not only the developer has to provide the information which component this is and which license it has, there are also other information that need to be considered, like is there some clarification if there are some cryptographic functionalities included, which can also which is also important if you want to export a product, or there are also like other information like does the component require specific runtime, like it is for the Java with the Java runtime environment. And so the developer has all to provide this different information, and this takes also time and slow down the whole approval process. Another thing is like the usage of the open source software in their products. It's not just necessary to know what kind of license it is. It also depends how the product is used. Like the company which is we studied, they differentiate between these 4 types, like here an on-premise installation, like if you provide a software as a cloud solution, cloud service. If it's used as a library to be integrated into another product of the company, or it's just for internal use. And this makes also the process a little bit more complicated because all these dimensions are not that you can choose one of them. You can have like multiple selections. And this introduces more complexity that needs to be represented somewhere. Another part is custom report. So also in the company we studied the management demands reports for their products, which included open source software. And this is also something to provide all these reports. There's additional tooling in place who collects information from different places, and sometimes the references between the information are not reliable, and then there needs to be a manual cleanup of the information. This takes time, and it's not really a good solution for them. So it's not like they can be derived from one data source and then it's done. Another part is like SPDX support. If you know the standard, it's really useful to exchange license information between 2 different companies or places in a structured way. But it is not enough to just have SPDX documents to exchange the data. SPDX doesn't say you which information is really needed to be in the document. So can you have a valid SPDX document which doesn't have the information you really need? So if you exchange such a document within a supply chain or so, the parties still have to agree on how certain information are stored in the SPDX document, and it just can't be processed automated without talking about it. Another aspect is here a central system to manage products. This is one thing that the company sees is very useful, to have a central place to store all relevant information, but it doesn't mean that it will solve all the problem. For instance, it's a problem for the company that some of the relationships are represented in a simple fashion. So relationships between here a product and its components, but also between a product and other products that is connected. If some product is part of a bigger product. And the simplification of the dependencies causes also problems because it's hard to generate precise reports from it. And then sometimes you need additional tooling again to solve this problem. Yeah, and here the question is, if there are all these challenges, what is the problem? What kind of problem does it cause? And the main thing is that the documentation doesn't represent the shipped product anymore, and this is not good. So what I'm now currently doing is with further research, I'm trying to conduct more interviews with other companies to see if all these challenges are company and the solution that the companies have in place are company specific, or it could be based on a unified model. And so this is here my last slide. We think that here a unified model to manage all these open source dependencies and the metadata could simplify the use of open source software and products. As I said, it's hard sometimes for companies to work each other on such a topic, And if we had such a model, it could help companies to have like a reference system, especially maybe for new companies who are starting to use open source software in their products. It could also maybe simplify the tooling by standardize some aspects, and hopefully this avoid too much additional work or tooling to derive information from a common system. Yeah, if there would be here one sentence that you should remember of the whole presentation, this would be this one. We think that such a model is needed, and this would be the next step to figure out how, for me, how such a model could look like. Okay, that was my presentation. Do you have any questions?
Thank you so much, Andreas. My question, so do you have any ideas regarding how this model should look like approximately?
Yeah, so yeah, sure, I have some ideas. So I have some different, there are different dimensions where I need with this my further research. I will go more into detail then. They're like here how dependencies are represented, how you can do it in a good way. There are also other aspects like what is delivery of a product? Is it just only the software? Is it something more complex? We had like the case, there a product, depending on the license key you have, maybe you have a like a light version where it just have some feature set and a heavy version with more features. Does it need somehow represented? Also, there are new challenges with the distribution of software like Docker. There are new complexities that's introduced, and there's also the questions, does such things need to be represented somewhere? And if so, how can it look like? So there are more things, but how the dimensions really look like, this is future work, and I'm working on it.
And just to have an intuition behind the possible solution, like do you have, if we talk about non-open source products, what are such, do similar models exist in the non-open source world? Like, do you have maybe examples of proprietary solutions that solve the same problem that you're trying to do?
Yeah, I'm not sure. I don't think so, because we couldn't identify anything that would solve such problems. And for that, we do this research to figure it out how to solve it.
Mm-hmm. So for now, you have nothing to compare with. Like if you come up with a solution, then it's a completely new. It will be a completely new solution that.
Yeah, there's like, if you look at it, I said sometimes the architectural documentation. This is something you could do like in UML, where you have just a representation how your software components look like, and in the other side, you could also represent so license and open source relevant information like the SPDX standard does it. But the question is, do we so we think we need to combine these two views somehow. So we have a model where we can derive things like the software bill of materials that is relevant for license compliance, or we could derive other things like this custom reports from a common model to have consistent results.
Mm-hmm. Okay, and is your plan to develop just the model, or are you going to develop also some tool support for that would make this model operational?
Yeah. So my plan is also to develop a tool. So part is here to develop the theory, the model itself, and then to show like a proof of concept. Also, we'll develop software that using this model and thus use to cover use cases like here, bill of materials generations from this model, and maybe cover some other aspects. Yeah, for that, I'm currently started to develop a tool. It's on GitHub and it's open source, but I'm at the beginning at the moment.
Okay, thank you so much, Andreas, for the interesting presentation. And so as for the next speaker, Vasily Kruglov, he wrote to us that he would not be able to join, unfortunately. And I think because he left to us the video of his talk, we're going to put the video so that you can watch it.
Okay, so I think I will start it, Alexander. Okay, one moment.
Okay, thank you.
Hello everyone, my name is Vasily Kruglov and I would like to present you my work related to development of control systems based on machine vision. Today I would like to show you that one particular moment of this research project which is related to usage of open source libraries such as TensorFlow and how this process helped to significantly reduce time costs in experiments and development itself. First of all, let me show you the problem which current mining and processing plants face with. The problem is related to grain size analysis of ore particles moving by a conveyor belt. Currently, this process is performed using a non-automated approach, when staff manually takes samples from a conveyor belt and then conduct analysis of the sample in the laboratory using sieves with different cell size. The result is grain size distribution of particles by each fraction. This process has several significant drawbacks as far as it is a labor-intensive process and it's impossible to perform such measurements with the desired frequency. Thus, process of scratching is in fact almost out of control because we don't know which parameters of equipment are better for the current context, and it leads to worse quality of the final product. We can say that in industry there is a demand for continuous grain size analysis of bulk materials throughout entire process cycle, which includes stages of crushing, pelletize, and etc. So there is a problem, and I developed a solution which helps to overcome this. The system based on machine vision for control of grain size distribution of bulk materials was developed. Here you can see photo of device capturing images of crushing ore with this device is mounted on conveyor belt at Evraz mining plant in Kachkanar. Let's talk a bit about algorithm part. Common for the system for grain size distribution control is the stage of dividing the entire image of the ore mass into fragments corresponding to individual pieces with the subsequent determination of their geometry. The segmentation procedure can be solved by highlighting the boundaries between fragments of ore pieces images. It is decided to apply convolution neural network for recognition of the boundaries of stones. TensorFlow library was used to create basic convolution neural network for the purpose of highlighting boundaries of stone in the image. Initially, the algorithmic part of the system was based on traditional image processing approach using homomorphic filtration and edge detectors, such as Canny detector. In order to increase accuracy of the system, it was decided to look for some other approaches like narrow analysis, and with help of existing open source libraries it becomes possible. The input data for construction, the boundaries of stones will be fragment of the images with the size of 50 by 50 pixels. The central point of the fragment either belong to the boundary of the regions or not. Based on these assumptions, all images are divided in two classes. Two separate images for classes. The borders of stones were drawn manually on the source images. In this site, you can see the original image and processed one where borders were manually labeled with red lines. These labeled images were used for training of our neural network. So the convolution neural network initially was trained for 10 epochs with binary cross-entropy as an error and RMS-probe optimization. The results show accuracy of prediction 90.8% for trained sample, and then on the test sample result shows predictions of boundary detection at the rate of 83%. To improve the efficiency of neural network, some experiments were conducted. It was decided to modify parameters like add additional layer and increase number of filters up to 32 filters in each layer. However, it was figured out that the convolution neural network with initial parameters gives better results in respect to boundary detection task. In this slide, you can see some examples of the output of boundary detection algorithm based on neural network. So, in conclusion, I would like to say implementation of such control system based on machine vision helps to increase frequency and accuracy of measurement dedicated to grain size analysis of crashing ore particles throughout technological process. It provides an opportunity to adjust parameters of equipment property according to current parameters of the process, and also it helps to control technological discipline of personnel. At the end, it helps mining and processing plants to improve the quality of their final product. In respect to the usage of open source components, I can conclude that for giving research tasks, it helps to conduct experiments in a quite effective way and receive significant improvement of the system accuracy with quite low time cost. Again, results in accuracy of the system is 83% for the test sample with overall performance suitable for constructing real-time systems. Thank you for your attention.
Okay, so because it was a recording, unfortunately, we cannot answer questions, ask questions. So we're moving to our next speaker, Nikolai Buldakov, who will tell us about an open source solution for smart contract-based parking. Nikolai, please.
Yes, hello.
Hello.
Just a moment. Is it seen?
Yes, we can see your screen.
Okay, great. Hello everyone. Today I'm going to present you our paper, which is called Open Source Solution for Smart Contract-Based Parking Management. So let's start. Here you can see how the presentation is going to be. So some experts give an estimation that with the current trend, more than 60% of the humanity will end up living in urban areas. And a lot of people this will obviously require considered management of the city services and their infrastructure. And one of the biggest issues to address in modern cities is the problem of managing parking area. Local authorities and entrepreneurs can find it challenging to locate places for new parking lots due to general privatization by private or public entities. And the most obvious way to handle this is to provide easy means of renting out such properties. And such approach is expected not only to simplify the process of creating new parking spots, but also it will help to collect and aggregate the information about the current occupancy of parking lots, which in turn will simplify the process of finding free spots, and this will be followed by decrease of traffic congestion. And the significant issue concerning the parking lots, another issue is the trustworthiness of the current systems, because they mostly use centralized storages, and this makes the sensitive data vulnerable. And also another issue is to provide is a possibility to provide malicious intrusion in such centralized solutions. The third important problem is the need for a universal system which will aggregate the information about parking lots in a way that guarantees biased treatment of all parkings, which will provide constant perspective of the entire situation. So we can formulate the problem in the following way. We have governing authorities, which are usually a city hall or some kind of municipalities, and we refer to them as the administrator. And their ability is to authorize the process in the cities and also have the people and companies which possess the land and also allow to this people access to the property, and they are willing, and these people are willing to provide land for parking in order to get some kind of let's say money or fees. And the third entities are tenants, and these are companies or people who are willing to rent out their parking spots on some basis. In order to provide the land for parking, the landlords have to sign the contract with the administrator. And this scenario, in this scenario, which we can see, the landlord sends the request, which has to be signed by both entities, the administrator and the landlord. This process is called a landlord registration, and it involves the check of the documents and legibility of renting the properties. And eventually the agreement contains such information as the registration of the land, and then the landlord can also subrent their property to the tenants, and they also make an agreement. Before proceeding to the proposed solution, we should also talk about some assumptions made. For instance, the parking lots can be divided into a set of spots, which we will refer to as parking stalls. And the second one, the parking lot has to be equipped with tracking devices which provide full observability, allowing to to determine which parking stalls are occupied at the moment and which are not. For instance, on this picture, you can see the parking has 3 tenants, and the system will help, with the help of the camera, can say if every stall is occupied or not. And for instance, number 13 here and number 10 are occupied and number 2 is not. Okay, let's proceed to the solution, to the proposed solution. It is based on the usage of the blockchain and smart contract systems, and assumes the full set of the whole set which we described before to be presented in the system. The city hall is responsible for the deployment of the system as well as the settings. And various legislation regarding landlord and so on. Also, it covers payments between cars and parking spots and landlords, and eventually also tax payments from landlords to the administrator. And the obvious property which we presume is that it will be secure, universal, and unbiased. But before proceeding, let's consider some related works which are already present. And most of these works use the centralized approach, and all of them inherit the classic problem of all centralized applications, because they rely on server that makes it vulnerable, on a signal server, which makes it vulnerable to provide trustability, and also it becomes just a single point of failure. There are also some centralized solutions, but their drawbacks is that they are not enough automated. They do overcome the disadvantages of centralized solutions, and they are based on blockchain, but they lack some scenario coverages. They don't cover many possible scenarios, and this is what we want to tackle. So now let's see the system design. And first, let's start with how we required, we elicited the requirements. All the requirements have been elicited in order to gather the requirements, and we have used several techniques. Sorry. First of all, we conducted an interview with representatives of the business. For example, a small parking solution company founded in Italy, which is called Partsmark. And the interview has shown some essential aspects of modern parking. And it also revealed common shortcomings of the system. Some parts of our solution, including service providers, blockchain and flexible pricing policies, and also what information to store, are inspired exactly by this interview. And we have also analyzed other existing services, both centralized and not centralized. And our findings about the drawbacks have been described and presented in the related work section. Finally, we have collected more than 30 user stories, and the key emphasis was again on safe, trust working way of conducting payments. And it was also essential to ensure that contracts are respected and the parking providers are treated in an unbiased manner. Now, here you can see our final system design. The parking system consists of thin clients, such as a mobile or web app, and each participant can access their part of the functionality through the thin client. Every thin client is connected to a local Ethereum virtual machine node, which in turn is connected to the rest of the Ethereum network. The local node has an instance of the ledger shared by all nodes and also hosts smart contracts. Whenever a participant wants to perform an action, for example, initiate parking or update number of free parking spots, the thin clients tell the EVM to invoke a corresponding method of some smart contract. The action is performed in the form of a transaction on the blockchain. The blockchain network contains a public ledger and updates the public ledger with the valid transactions only. A consensus mechanism is used to verify the transactions. Once the new transaction is verified, the public ledger is updated and the local copies of the ledger in each node are synchronized, and all the participants can observe the new state of the parking system. Here you can see the smart contracts which we currently have. They are the back-end part of the system. The logic is distributed among several contracts which correspond to logical components of the system. There are two types of contracts. Some of them are deployed manually and others are deployed dynamically by the system. The parking system, let's start with the parking system. It's the first contract to be deployed to launch the system. It is deployed by an administrator, for example, a city hall, and it implements the main management functionality of the system. The parking system contract is responsible for the registration of new parking lots and cars, as well as for storing addresses of all other entities in the system. parking provider. Is an abstract contract which cannot be used on its own, but it should be extended in order to be used. Both tenants and parking lots extend this contract. Service provider. It is conceptually a third-party entity that collaborates with a parking provider in order to place information about their parking spots on their platform. Renting contract. Contract implements a relationship between a parking lot and the tenant in such a way that both parties are guaranteed that their agreement will be respected in the system. Payment policy is a protocol that defines two methods: get payment rate at a particular moment and get total price for the parking given given the start and the end time. It can be custom, and every parking provider implements their own policy. Other contracts represent the actors of the system, and we already described them as roles in our system. Now to the topic of how the front-end applications can access the contracts. In order for the front-end distributed applications to communicate with the EVM, there has to be a specific data interchange format. This format is called JSON RPC, and it is utilized through a JavaScript library called Web3.js, which allows us to interact with a local or remote Ethereum node using HTTP or IPS connection. Every front-end module of the distributed system communicates mostly with their own smart contract, and this contract in turn is responsible for interaction with the parking system and other modules. The last topic we discuss in this paper is the implementation of a micropayment channel. In order to ensure trustworthiness between a parking provider and the car at the moment of parking, a micropayment channel in form of a smart contract is established between the two. This way we ensure that the car pays exactly as much as it has to for the service it receives, and that both parties don't have a means to trick one another. Here's the high-level workflow of how the channel is used. First, the driver deploys a contract with locked funds of some amount that exists any possible parking period. Second, driver emits messages directly to the service provider, and the messages are microtransactions containing the amount transferred. The parking lot can check the validity of the messages as they are signed by the car. And finally, after the parking process is over, the service provider can use the last message to retrieve the claimed amount of funds from the contract, and the rest of the locked funds goes back to the car. So this was the high-level overview of the system which we propose in our paper. And now let's jump to the conclusion. So a significant amount of research has been conducted on smart parking, and in this paper we have examined some of the recent work related to this topic, and we propose a solution. Interviews. We have conducted interviews with the main experts, user stories, we defined user stories, and a system architecture has been proposed with a case study. Our solution allows independent owners of parking systems of parking space to be integrated into one united system that facilitates the parking situation in a smart city. The utilization of such a system raises the issues of trust and transparency among several actors of the parking process. And in order to tackle those, we propose a smart contract-based solution that brings in trust by encapsulating sensitive relations and processes into transparent and distributed smart contracts. Thank you.
Okay, thank you, Nikolai, and Alexander. Thank you for chairing this session. Also, thank you for helping him. It was a great work, guys. So really